I'm Alexandra. Nice to meet you. Okay, yeah, stand.
All right, guys, let's go ahead and get started.
Wait, you want to do it? Oh, okay.
Did you guys all have a good weekend? Good restful weekend? Sounds good to me. For the first 5 minutes of class, I'm going to ask you guys to come up and populate a list of questions you might have, whether it be about the quizzes, the homework assignments, in-class activities, or anything really in general. And so I'll leave you guys, I can either leave if that makes you guys feel more comfortable to put them up here, or I just want a list of questions so I can go through them, and if I don't do that, then if this works. That should be working. Okay. Then I'm just going to go through the study guide again and go through what I think is important. First off, in-class test is 10 multiple choice questions and 3 short answer. We've got a bit of questions about that. And it should be enough time for you guys to finish in 50 minutes. Are there any other questions before you guys write on the board and get some more questions up there? Yeah.
Where's the study guide located?
I'm sorry?
Where's the study guide located?
It is on Canvas. If you go to Files, it is right here, Stat 36. So right away. Any other questions? All right. Well, if you guys have questions about any quizzes or anything like that, I want me to go over, put them up here. I don't know whether to sit out of the way. Feel free to use any marker if you would like. Don't feel shy. This is just a way to... And there is no dumb question, by the way. So even if you have a question, what is the statistic or what's a parameter or anything like that, that's an absolutely fine and legit question. So. Yeah, it's a good one. You can use the red one too if you want. If you prefer.
Are there any practice short answer questions in though? Or just in, like, look on the notes of those short answers?
I would definitely look at the in-class activities and homeworks because they're going to be like that.
Okay, that's
But I'll see if I can come up with one or two of them to put out.
okay, wait, also it says we need to pull it off your shelf computer to take the exam, so is it, like, will we have our?
No. So I just meant calculator on
Okay.
that. I haven't changed it. I changed it in here, but I didn't re-upload it.
Okay.
So. Any other questions? All right. Well, I'll go ahead and start answering some of these. Erase some of this here. Oh, there you go. Mhm. Sounds good. All right, so let me see where I can start off here. I'll just start from the top. So confidence intervals. Generally, for the test and about confidence intervals, the only thing I've really talked about so far is talking about the margin of error with confidence intervals. And so essentially what the concept is that when you're repeating this study and continuing to do this over and over again, 95% of the time you'll get a parameter or a statistic out of your study, out of your sample, that will fall in a predetermined interval. And so one way that we've calculated this before is say our population is 3 million, and I conduct a sample of that's something easy to do. Alright. So I conduct a sample of 625 to try and understand something about this population. And so, since I know my sample is 625, I can calculate the conservative margin of error equal to this. And this will give me a proportion and not a percentage. And so out of this, I get 1 over 25, which is 0.04. And so from this, I now have a 4% margin of error. And I can create a confidence interval around a particular proportion I talk about with this. So we talked about proportion of adult Americans that are very interested in religion. So let's just go ahead and stick with that. And let's just say that proportion is 0.48. So that means the confidence interval for this proportion is between 0.44, which is 0.48 minus 0.04, and then we have 0.48 plus 0.04 to get the upper limit. So that means if we continually reconduct this study, if I took another sample of 106.25, another one, on average, 95% of the time, we will get a parameter that reflects, percent Americans very interested in religion. Let's just say that. And this is what we're talking about. When we repeat this study over and over again, on average about 95 out of those 100 times, or 95% of the time, we will get a parameter we'll get a new number of this that will be within this interval. Yes?
Where did you get 0.48 from again?
I just came it from the top of my head. It's a statistic from the sample. So if I were to just say 625, then that means, I do 0.48 times 625, that 300 people said that they were very interested in religion. So that 0.48 just comes from 300 out of 625 people. Yes?
So when you're doing this, you could just pick up a number, any number, and subtract what we got from it?
No, so the number has to come from the study, so either I'll specify it or you have to calculate it. Yeah. Great questions. Any other questions? We're going to talk more about confidence intervals in the second half of the course later on. So while I do think they're important, the only thing you need to be worried about is doing the margin of error of a study with it. Okay. Any more questions about confidence intervals? All right, great. Let me just erase this. Okay. So, margin of error. Okay, least squares. So we will probably get to regression specifically in the later half of the course when we know how to understand all of the assumptions behind it and why it works besides just calculating a regression line. Essentially, least squares is the technique we do in order to get the estimates for, if I have the equation y equals b0 plus b1x, right? This is the typical regression line. Least squares is the estimation technique that allows us to get estimates for b0 and b1. So where it says in the book, let me see what page it's on so you guys can look at it. And this would be something I would want to include on my cheat sheet if I were you. b0 equals y bar minus b1 x bar. Then b1 equals summation xi minus x bar. And then y minus y bar over summation of xi minus x bar squared. That this technique, we get these equations from a least squares approach. Basically meaning least squares is, I guess, code name for minimize squared errors. So if I have a regression line, and let's just say this is the best fit, what I'm doing is, what I'm doing is I'm measuring the distance between this real point and the predicted point. And then basically, I want to minimize whatever this value is squared to the line. So there's other techniques, like if I were just to measure from the median, I could do that in a regression sense. But all of the ones in this case, least squares refers to minimizing squared errors when we make this line. You don't have to know what the least squares technique is. Like specifically, you don't need to know that it minimizes squared errors for the test. Just good to know. You do, however, need to know how to calculate these, because that was very much touched on in chapter 3. I think it's very important that you guys know how to calculate that and how to interpret it and all that type of stuff. Any other questions about least squares? All right, well, I think it only makes sense to go into regression lines after this. Would it be beneficial to you guys for me just to go through a problem involving least squares? Would that be helpful? Okay. All right, so let me go through a question in the book. Okay, I'm gonna go through question 3.86. It's on page 109 of the book. So it is between body weight and chug time. And so I'm gonna put it up in this corner over here. Right. So this. And so suppose we have this data, and somebody asked us to calculate regression line under least squares. Okay. And so if you were doing this problem, what would be the first step that you would take? Because I already know what I would do to solve this problem. I want to see what you guys know. So what would, if I give you this data set, and I tell you to calculate what the regression line is, what is the first thing you might want to calculate for this data set? Yes? That's right. The mean of both x, which is this x and y. So which one of these is my explanatory variable and which one's my response variable? So usually we say the x, the explanatory variable, helps reflect the change in variation of the y. So the first thing I'm going to calculate here is x bar and y bar, because as we know, the equations for the y equals b0 plus b1x we had, and this b0 is this equation, and we have a whole bunch of summations over here. Okay. And so in the first case, you can see what is used the most amount of times is both x bar and y bar, the means. So what we're going to want to do is calculate x bar, which is the summation of xi. Can anybody tell me what the notation xi means? So what am I talking about xi? Am I talking about all the data? Am I talking about one point? Am I talking about a whole variable? I'm sorry?
All of the data?
Right, but this little I underscore right here is talking about each specific data point in here. So in this, I goes from 1 to 13. So I'm summing up all these numbers and dividing by how many there are. And so, because I am too lazy to add all of that in my head, I'm going to use my handy dandy calculator on the screen right here. So 153. And I would really appreciate it if somebody can give me the y bar for the chug time as I calculate this. Okay, and I I'm just going to shorten this to 178.85. And so similarly for y bar, what you're going to do is sum over the y's. And so it's this whole set right here. Did anybody calculate on their computer calculator what the y bar is for this question? 5.11. All right. Great. So now we have x bar and y bar, and we can plug them into these equations. So are we done? Did I get the b0 and b1 from this yet? No, of course not. What we need to do is then calculate what each point is subtracted from its mean. And so one way I find this to be easiest is to add another column to this. So I then have xi minus x bar, yi minus y bar, and then I have xi minus x bar. Just for ease, I'm just going to round up the whole numbers here. So I'm just going to have 5 here and 179. And that is all I need, right? Okay. And whenever I have a summation sign here, I don't specify what the indices on it. These always go from I equals 1 to n, the sample size. So for this question, what is my sample size? 13. Yeah, that's right. You count up how many x and y pairs that I have, and I have 13 here. So it would not be 26, not the number of x and y points separately. So I have calculated my x bar and y bar. And now I'm going to go through the list and calculate what the xi, this point, minus x bar is. So 153 minus 179 is negative 26. And then 169, negative 10, negative 1, 19, negative 51, negative 4, negative 2. This would actually be 4 here, because that's greater. Yep. Just check my math. All right. 210 minus 179 is 41. And then 243 minus 179 is 64. 208, 29. 157 minus 179 is negative 22. And then negative 16. And then negative 21. All right. So now I have a whole bunch of these. And what I'm just going to do in my calculator is add all these up. Right. And so I'm going to have another column over here. So x bar equals 179, y bar equals 1. Just so we can simplify. And I'm going to multiply these two numbers together because that's what I'm adding up over here. As I'm adding up, would be adding up all of this column divided by this column over here. And so let me just do the yi minus y bar. taking a little bit of time, but it's important to know how to do this. Then we take this column and square it. And so I'm just going to do my calculator by doing that. Say 76, we got 100, 1, 361, 1, 16 for 41 times 41, 1681, 64 times 64, 4096. Four, 256.
And this is like the individual. So we got 26.
And then I add all of that up to get.
Yeah. That second column is you do save the y's, and you take this, plug it in, square everything, and just do that one. And then you just multiply these two. It's just like a step by step.
It's so much, yeah.
It's a lot of numbers, but if you focus on one column, it makes sense.
Right.
To get 11,550. And that is the summation of xi minus x bar.
I'm switch them. This gives us the same one that we talked about before.
Gotcha.
And then if you go to the
Then I multiply these two columns together. And just for ease, I am just going to say I get something like 2,000.
Yeah.
Let's just say I
And
get
then this is the
when I sum them all together. But ideally what you would do is just multiply these two columns together and add them up to get what this top term is. So then B1 is 2,000 divided by 11,558, which is 0.17. And so B0 is just y bar, which is 5 minus 0.17 times 3.43.
Yeah.
So B0 equals negative 25 point. Alright, so now we know that the regression line for this equation is y hat equals negative 25.43 plus 0.17x.
Gotcha.
Alright. I know that was a little complicated, but it'll be a shorter question on the test. I won't have as many numbers as this, so it'll be easier to calculate. Yes?
How did you find the x bar and y bar?
Right, so the equations for x bar and y bar are simply y bar equals summation of yi's divided by n. So y bar is just the arithmetic mean, which is just adding up all of these numbers and dividing by 13 because that's how many there are. Does that make sense? Okay. You do the same thing with the x points as well for x bar. All right. Any other questions about the regression line? Yes?
For B0, the equation that you did, I'm looking at the numbers, it's 5 minus 0.17 times 0.79.
Times, let me write that.
Is that because you're subtracting 0.7 from 1 or something, or?
What I'm doing is this equation right here. So
What's the 0.7?
the 0.17 comes from my calculation of B1,
Yeah.
and then the 179 comes from what I calculated as x bar.
Oh, it's 179.
Yeah. I have bad handwriting. I'm sorry. Let me make that more clear. 179. All right. Are there any more questions? Yes.
Where'd you get the 2,000?
I didn't want to do the time and take the math to do these two columns multiplied by one another.
Oh, okay.
So I just made up a number for that, just to show how I would calculate what the B1 is. Yes.
When you are multiplying those, do you add them all up first and multiply the sums? Or do you
No.
multiply like 0.6 by negative?
Exactly. The second part is completely
Okay.
right. So you multiply these two,
Uh-huh.
and then these two,
And
and then
then
these
add all of
two.
those up?
And you go all the way down until you multiply these two. Then you add those up
Oh,
together.
sounds good, thank you.
So the answer for B1 is 0.17.
Yes, that's right. So B1 is 0.17, and B0 is negative 25.43. And that's what the regression line would be from this, and then you can plug in a new x point to get what your predicted y value would be for that point. All this will be going up on YouTube either tonight or tomorrow morning, depending on what files. And so if you have any questions, you can go back through and answer me a question tomorrow at office hours from 5:30 to 7:30. Any other questions? All right. So I know that was a long-winded explanation about regression lines, but I digress. Am I all right to remove this now? I saw some of you were taking pictures and stuff. So. Good to go. All right. Alright, so regression lines were covered. Stratified sampling versus cluster sampling. That's a great question. I some of you having a little bit of difficulties, the distinction between the two. So, stratified sampling. Comes in two steps. So I have step one is choose a strata or group that you want to sample from. Choose a strata. And then step two is conduct a simple random sample. Sample in each strata. And the distinction with clustering and cluster sampling comes in where step one, you choose a strata or grouping factor. And depending on your situation, you may want to choose a different strata for stratified random sampling than you would a group for cluster sampling. And the difference here is that step two, choose conduct. And I'm just going to abbreviate it SRS. Since you guys know what I'm talking about. Conduct an SRS of full clusters. And that's the key word here. Where strata, you're doing a simple random sample in each. When you're doing clustering, what you're doing is you're picking out the clusters and you're using everybody in that particular cluster, every participant, every subject. So you can't just simply, oh, I'm going to find this cluster, I'm only going to take 10 out of 20. No. For cluster sampling, you have to take the results of everybody in that cluster. So main differences, SRS any strata, SRS all of the clusters. So if I was doing like a basic geographical question where I had northeast, east, south, southwest, north, west, and then southeast, and then northwest here. And if these were the strata that I was choosing for stratified random sampling, is I would maybe just say pick 10 and do a sample of 10 here, sample of 10, 10, 10, and so on to conduct my sample. If I was doing cluster sampling, I would say I'm going to use a simple random sample to pick 2 of these. And suppose the random numbers by which I selected chose southwest and northwest. Then I would sample everyone out of these clusters. Does that make sense? Great. Wonderful. All right. Quiz question number 4, the residuals. Is this the one with the 120 with the dollars in advertisement? Was that the question? Okay. Sure. Well, let me get that. Quizzes. All right, question 4. So a regression between stores revenue, Y. So when I'm writing this down and thinking about it, I want to write down what my Y and X variable are and the units of each. So Y is stores revenue in thousands of dollars. So if I tell you Y equals 10, this means $10,000. So this is the Y. And the X in this case is advertisement spending in thousands of dollars. And the same type of rule applies here. If X equals 10, it means $10,000. And so if I create my regression line that says 120 plus 0.23x here, and I say that one store spent $40,000 on ad spending, and got $140,000 in revenue. So what is my X true and Y true for these points? Can anybody tell me? So this would mean that if X equals 40,000 in my model, that means X equals 40. Because from this conversion that we saw below, in thousands of dollars, I divide this by 1,000 to get back to what my units are in my model. Same thing for the Y true is 140. And so what you need to do, and I asked for the residual in this case. So the residual is Y true minus Y hat. And so we know what Y true is 140 here. And so if we plug in y hat equals 120 plus 0.23 times 40. What we get is 120 plus 9.2. So the predicted sales for this store would be $129,200. That's what would be the revenue. And so when I'm calculating the residual, I go to 129.2, and then the result of this is 10.8. And if I translate back to dollars, what I get is $10,800. Does that clarify some of the questions you guys were having about this? It was a little tricky with the units here. All right. That's with that. Question about double dummy versus double blind. Right. So, am I right to erase this? Yes.
Yeah, well, I took pictures this time, but, where does the 40 come from?
The 40.
Yeah.
It comes from what I was saying up here. So one store spent $40,000 on ad spending. So if I tell the units are in thousands of dollars, and I say they spent $40,000, that means in my model, and here, X would be 40
Okay, so then you would just have to convert it back.
to regular dollars at the end. So since I got a Y minus Y hat of 10.8, you multiply by $1,000 to get $10,800.
Okay, that makes sense.
Cool. Any other questions? Yes.
Can you just keep X, like make X 40,000 and then make 120,000?
Not in this case, because what B0 and B1 were calculated from were from 40 and, well, were from the original data, descaled. So they were in like tens units instead of thousands. So if you were going to go back and recalculate, you need to recalculate your B0 and B1 for thousands of dollars normally, and then you could just plug in these real numbers. Because if you just plug in, 40 and 140,000, you get one and get the other answers up here. I think it's maybe negative 112 that you can get. Any other questions about this question on the quiz? All right. And since this is the same, when you said quiz 3 question 7, is that quiz chapter 3?
Yeah.
Okay. All right, so let me go down to that one. Right. So when we're looking at this in JUMP, and I'm just going to write a little bit up on the board. This real quick. So when we're looking at this in JUMP, we have intercept, and we have height here. And so we have 2.47, 5.41, and so it's conducted on 252 men. Height is the explanatory variable, which is the x, and underwater weight is the response variable, which is the y. And so in this equation, the estimated regression equation, since this was conducted in JUMP, it has calculated what the B0 and B1 are. So this top number, intercept, over here. So this top number, 5.411, is B0. And the bottom number, height, is the estimate for B1, calculated under the same least squares estimation. And so in this case, y hat is 5.41 plus 2.47, the variable type. Or you could have x here in this case, but it's the same regression equation. Does that make sense? Cool. All right. So we got that question. All right, and about double dummy versus double blind. So a double blind procedure is where the practitioner, the person giving out the pill, is blinded, so they don't know if they have a placebo or drug. And with the person receiving the drug, they also do not know if this drug is placebo or real drug. So that's what a double blind procedure is. Double dummy is essentially when you have groups where you have group 1 and group 2. So for one study, they get a placebo, and these are two different drugs. So they get a placebo, and then this is drug B, and this is drug A, and they receive a placebo. So it's just a specific case of like a multiple stage study in which both groups receive a dummy at least one time. Does that make sense? All right. Now we have about 3 minutes left. Let me get to this. So empirical rule, essentially, if you have a normal distribution, they tell you, oh, I have a normal distribution. Empirical rule refers to the sample standard deviation of the curve around its mean. Bar plus S plus 2S, 3S, S. And essentially, what this is telling you is what proportion of people under this curve fall within values in this data. And so without actually calculating out of the data itself, you can calculate what the intervals are. So if somebody told you, and I believe the numbers are something like 68.7% within one standard deviation, 95% within 2 standard deviations, and then 99.7%, or most of the data, within 3 standard deviations. So if I give you what X bar is and S is, you can tell me that 95% of the data falls between X bar minus 2S and X bar plus 2S on this side. You can get an error for this. Does that make sense? Essentially, if you're just going to put this on your cheat sheet, I would just have the graphic with these numbers underneath, and then generally what standard deviations are referring to. And lastly, before you pack up, talking about confounding versus lurking variables. So the main difference here is that confounding variables are in your study that affect both the explanatory and response variable. Lurking variables are ones that aren't measured in your study, but they could have an influence on both the explanatory and response variable. In essence, why they're lurking. All right, do you guys have any more questions before we head out? All right, office hours are going to be tomorrow night, Saunders Hall 408, 5:30 to 7:30. Come with any questions you want, I can help you go through. Thanks, guys. Great day.
I'm still working on it.
Oh my God.
Because I never do this in the calculator, so I have to do the math.
Yeah.
Because